Hello and welcome into another solving of LeetCode challenge on this channel. Today we'll be dealing with an easy one, search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O of log n runtime complexity. And we have like examples 1, 3, 5, 6. The target is 5. We are returning 2 because 5 is under second index. And the example second is target 2, 1, 3, 5, 6. The output is 1 because the index we want to put in would be between 1 and 3. So the index would be 1 from 0 based array. Alright, let's think about it for a moment and see one of the possible solutions after a short break. Alright, so we are back in the LeetCode console. I will be using JavaScript, but you can use many other languages as well. So let's write ourselves some basic example here. Let's do it this way, maybe, and let's think about target being 2. And we need to do O log n time complexity. So here the issue with O log n, so the very basic solution that we could come up with would be just a basic for loop and iterate through whole the array, but then it would be a log O of n. To achieve log n, we will need to implement a binary search. So we can do it because we know that the array is sorted already. So the idea here is that we will, let's code some code and then explain that. So we will instantiate something which is called pivot. We will instantiate a left index, which would be 0, and a right one, which would be the end of the array. So it will be num's length minus 1. So the idea behind that is that we will be slicing this array so that we can achieve the O log n. So we will be shrinking the amount of data we need to search between every time by 2. So let's code it, and that should make a little more sense. So the left one will be instantiated here at the beginning, and right would be this one. So we will be slicing this array from left to right, right in the middle, and then we will be checking where we are right now. So if the target is on the right side, or is it on the left side, or is it right in the middle. And when those, in binary search, when those markers cross, so let's say left will cross right, or right will cross left, and we will not get an answer, we will know that we don't have the solution. So we will be doing a while loop till they don't cross, or the pivot will be exactly the value which we are looking for. So let's code that, and we will start with a while loop. So let's do here, if left is less than or equal to right. What we would like to do in this time. So we will do a pivot, which will be a mathematical equation. So we will take current left, and we will add to it mat floor from right, from right minus left slash divided by 2. So the idea behind this equation is looking for this middle ground between. So right now, if the left is 0 and the right one is the end of the array, we will take the left, which is 0, and then we will take right minus left. So here we have like 3, 4, 7, so it will be 6. So we will be 0, 0 plus 6 divided by 2. So we will get 3 here. So here will be our pivot element, and then another thing we want to do, we want to check if the pivot match. So if pivot equals target, we will just return the pivot, because this will tell us that we found the solution. So the pivot is actually at the target value. Okay, sorry, we need to make it this way. So we need to not the pivot, because the pivot is an index. We will return a number which is under the pivot. Yeah, and then in the other case, we need to check. So we need to verify where is our target. So is it on the left side or is it on the right side from the pivot? So we will do it this way. So if target is less than nums at pivot, then we will know that we need to check the left side of the array. So if we need to check the left side of the array, we will change the right marker to be our current pivot, -1. So let's do it. Right pivot -1. It will be -1 because we already know that it's not the pivot. We checked if the pivot matches. So this will be in the one example, and in the second example we need to do it with a left one, because we will know that the target will be on the right of our current pivot. So we will like shrink the left side. We will drop everything from the left because we know that it's not the current answer, but this one will be +1. And after all of these things being done, after all the whole loop went and we didn't find the match, so the pivot never was, the number at pivot was never a target, we will return left, because this will be an index at which we need to insert this particular element. So let's delete this comment line and let's run it and see if it works. Alright, the basic cases are accepted. Let's run the whole suite. And yeah, we are accepted here. So that was a little bit complicated if you don't know what binary search is, but binary search actually is quite a common example of such problem to solve. So for sure, in another challenges, there will be more implementations of binary search. So this knowledge that we gained today will be used and more experience will be gained. So thank you for today and see you next time.